Last time we have classified matter based on their phase or state, so matter can be solid, liquid, or gas. Here, we're going to classify matter based on their composition. Let's start from the simplest form of matter. We call them as elements. The periodic table of elements shows the 118 different elements. Again, these are the simplest form of matter, meaning I cannot turn this into simpler substances anymore because again, these are the simplest form of matter. These are the elements, and elements, two or more elements can combine to form compounds. So compounds are made up of two or more elements chemically combined in fixed proportions. An example of a compound is your sodium chloride. This is your table salt, so it's composed of two elements, sodium and chlorine. Now, elements and compounds are referred to as pure substance. They have definite composition and properties. So let's take some elements as an example. Let's have sodium metal. So sodium, this one has definite composition. In this case, since this one is an element, it's only made up of one type of atom. So again, elements are made up of one type of atom. Meanwhile, compounds, by the way, they're made up of two or more types of atoms, two or more types of atoms. Now again, for sodium, since this one is an element, so this one is purely made up of sodium atoms, so that's its composition. Now it also has its definite properties. For example, sodium, it's always silvery in color, and then this one is a very reactive metal. It's a very reactive metal. Another element is chlorine. So chlorine is a yellow gas. It's actually a yellow poisonous gas. So it's a poisonous gas. So these are the properties of these elements. Again, each element has their definite composition. They are purely made up of one type of their atom, and then they have definite set of properties. And the same is true for compounds. So again, for compound, this one, it has definite composition. So this one has one sodium atom for every one chlorine atom. Other compounds, for example, we have carbon dioxide and carbon monoxide. So in this case, both of these compounds are made up of the same elements, carbon and oxygen, but these compounds are two different compounds. So again, each compound have their fixed proportions. In this case, for every one carbon, we have two oxygen atoms. Then here we have one-to-one amount ng carbon atom, then oxygen atom. So again, these are for the pure substances. They have definite composition and properties. One thing to take note, by the way, so this one is made up of sodium and chlorine, but take note that that even though this is made up of sodium and chlorine, this one will have a very different property. So it will have a different appearance and a different set. It will have a new whole set of its own properties, and this can be shown here. Again, sodium, this is a very reactive metal, chlorine, a poisonous gas, but when they mix, they form sodium chloride, which is a very safe uh, substance. Of course, we even add this in our food. So again, this NaCl here, it will have a different set of properties, different from its constituent elements. Now, different pure substances can form mixtures. So, mixtures from the word mix, these are made up of two or more substances combined physically in variable proportions. Now, this definition is very similar to the definition of a compound because a compound is also made up of two or more elements chemically combined. So, how is a compound different from a mixture? Let's take the air, for example. Is the air a compound or is the air a mixture? Because as we know, the air is composed of different elements. We have nitrogen gas, so this one is an element. We also have oxygen gas. And then we also have some compounds, for example, carbon dioxide. Now, is this a compound or a mixture? So in this case, they are just mixed physically. So here, it's still separate na oxygen atom, it's still separate na nitrogen atom. So here, they just happen to be on the same space. So here they are combined physically. On the other hand, for let's say sodium chloride. So if we take the particles of sodium chloride, we'll see that for every one sodium atom, it's chemically bonded to a chlorine atom. So again, this is its structure. So here, NaNCl, so they are chemically bonded. So that's that's the difference. So for a mixture, they are physically combined, so there's a physical combination. Meanwhile, for compounds, they are chemically combined, so there's an actual chemical bond holding these particles together. Now, because of this, a mixture doesn't have a definite set of properties, so its properties are changing, and it retains the original property of its components. Let's take, for example, salt water. So salt water, this is made up of salt and water, salt plus water. So let's have two samples of salt water, two samples of salt water. Now here, let's say this one has more salt. Let's say here it contains 50 grams of salt. Then we have 100 grams of water. Then let's say here this one is less on salt. Let's say 25 grams of salt. Then the rest is water. So in this case, this shows that this one is a mixture because again, it doesn't have its proportions between its components are changing. So again, it can be on some cases less yung amount ng salt, then on some case kaya more than ang amount ng or more than yung amount ng salt. So again, for a mixture, its composition is variable. So nag-change yung proportion ng components in the mixture. Also, this doesn't have a definite set of properties. So for example, on this type, in this sample of water, this can be very salty. Meanwhile, this one is less salty. So hindi consistent yung property ng salt water. Another, it retains the original property of its components. So for example, when I boil this one, so on this case, first mag-evaporate yung water, and then after mag-evaporate yung salt, because again, these are still separate na substances. So here, there's no chemical reaction happening between the salt and water. So it's still salt and it's still water. On this case, since mas first mag-boil ang water, so the water will first evaporate, then afterwards, the salt, which has a higher boiling point, will stay in the container. Now, for mixtures, so this one is obviously a mixture because it's obvious that it's composed of two or more substances. This one is also a mixture, but it's not very obvious because here, pantay or even yung pag-distribute ng mga components ng mixture. Now, these two types of mixture, so the first one is a heterogeneous mixture. So the composition is not uniform throughout. So here, it's not equal or pantay ang pagka-distribute, so it's not uniform throughout. Meanwhile, for a homogeneous mixture, it has a uniform composition. So hetero, it means many. So here I can see that it has, I mean, in terms of appearance, it has many forms or types of appearance. So there are different texture, different colors on this one. Meanwhile, for a homogeneous mixture, so even though this is composed of different substances, for example, this one is a salt water. So uniform or pantay ang pagka-distribute sa salt on this mixture. So I cannot see this on this sample. Now, how about this one? This one seems to be a homogeneous mixture. This one is milk and this one is a blood. But if we look under the microscope, it's actually that these are the microscopic view of milk. So here, we can see that it's not even, diba? It's not even yung pagka-distribute ng components ng milk. So some have liquid and then some have that powder, have that powdery something. The same for the blood. So here the rest are liquids, but some have this particles. Now this milk and blood, they are still heterogeneous. So they are heterogeneous when the composition is not uniform throughout. If we look them under the microscope, meanwhile, for a homogeneous mixture, it's still uniform because I still cannot see the particles or the components of each component in the mixture.